All right, this first slide is just a review of the parent function for y equals the sine of x. Our domain is all real numbers. Our range is -1 to 1. Our period is 2 pi, and then it's an odd function. And then here is a bunch of ordered pairs, giving you that first revolution. Here is the cosine function and its parent, the domain, the range, the period, and that's an even function. And then here is one revolution. So what we're going to do is we're going to continue applying our transformations that we learned in the previous lesson. And we're going to graph this function, y equals 3 sine of 2x minus pi over 3. And we're going to do one revolution. So let's identify the amplitude first. So we need to identify the a value. Our a is 3, so we're going to take the absolute value of that. So our amp is 3. Our a value is positive, so we do not have a horizontal reflection. Then we go to our b value, which is 2. So we're going to find that length of one revolution. So we're going to take 2 pi over b. So 2 pi over 2, which is pi. So one revolution will take pi. There is not a plus or minus d at the end, so we do not have a vertical shift. Then we do have a phase shift that occurs. So we identify this parentheses, 2x minus pi over 3, as a phase shift. So we're going to start with the left endpoint, 2x minus, it's got to catch that again, 2x minus pi over 3, and set it equal to 0. And then the right endpoint, 2x plus pi over 3, equals to 2 pi. And what we do is we solve for x. So we're going to add, it should be a minus here, add pi over 3 to both sides. And then multiply by 1/2 or divide both sides by 2 to get rid of the 2 on the left side. So we get x equals pi over 6. The right side we can't divide by 2 yet because we have to combine those two terms on the right. So I'm going to change that 2 pi to 6 pi over 3. So I can add those two fractions together, which is 7 pi over 3. Now I can divide both sides by 2 or multiply both sides by 1/2. Now we multiply across. So this is your left endpoint, and then this will be your right endpoint. And then you're going to split the left and right endpoint into 4 equal segments. So I'm going to say this is my starting point, pi over 6. Then I'm going to do a segment, a segment, a segment. I'm going to extend that line a little bit, and then that last segment. So this will be my right endpoint of 7 pi over 6. Now I need to split it in half. So I'm going to find the halfway point between pi over 6 and 7 pi over 6. So I'm going to use my midpoint formula. I'm going to add the two endpoints, and then divide by 2. So pi over 6 plus 7 pi over 6 is 8 pi over 6. And then when I divide that by 2, that's the same thing as 2 over 1. So we have to keep change flip. So 8 pi over 6, change it to multiplication, and then flip it. Multiply across, and then simplify. So we have a common factor of 4, so it's 2 pi over 3. So that's our halfway point. Then we would do the same thing again, find this halfway point and that halfway point by using the midpoint formula. The midpoint formula is take x sub 1 plus x sub 2 and divide it by 2. You're averaging them. From there, we're going to go ahead and do our amplitude of 3. So we're going to go 3 up and 3 down. Now we're going to graph our function. So if we remember, this is a sine function. So the parent for a sine function starts in the middle, goes up, and then comes back down. So we're going to do that same pattern. So it starts in the middle, works its way up to that first increment, the middle, the next increment at the bottom, and then the middle. So here is our sine function with 1 revolution. The distance is a period of pi, an amplitude of 3, and then a phase shift right pi over 6.